Alright, boys and girls, welcome back to the drive-through. Special shout out to Shoshi, Nick, Renata, and Morgan, new members of the Sin Lab. Let's go! Alright, here we go. 6-5, the tortoise and the hare. So hopefully you've read this. You've got two different equations that represent the distance that these animals have traveled over time. Ugh. Oh, come on. So, here, let's put time, Carson. Here, let's put the tortoise. And here's the hare. Okay, now time is in t per seconds. The tortoise's equation, let's see, is t squared, right? And the hare's equation is 2, whoa, what on earth? Fusonic. 2 to the t. Let me pause. Alright, I have those switched. So the tortoise is 2 to the t. He's the one with the head start. Duh. The tortoise is 2 to the t, and the hare is t squared. Okay. One of the hardest things about algebra is reading carefully, following the directions. All right. Let's just take an investigative look at this, Carson. Okay. So let's look at it after 0, after 2, after 4, and after 10. Okay. All right, 2 to the 0 power. Anything to the 0 power is 1. Very good. Okay. Okay. 0 squared is 0. That's what he means when he said he's giving the tortoise a 1 meter head start. So after 1 meter, the tortoise is, after 0 seconds, the tortoise is 1 meter ahead. Right? After 2 seconds, what's 2 to the second? What's 2 to the second? So after 2 seconds, they've both gone 4 meters. Okay? Now, 2 to the 4th, 2, 4, 8, 16. Where 4 squared is also 16. Could that be right? 2, 4, 8, 16. 4 squared, yeah. 2 to the 10th. You need a calculator.
1024.
10 squared is just 100. So notice, remember when we said we want our money to grow like bunnies? This is exponential growth. This is quadratic growth. Look how much faster the exponential goes. Okay? Alright, so let's see if we can use those to answer our question, and then we're going to hit up Desmos. At what time does the hare catch up to the tortoise? Well, I think it's at 2 seconds. Right? That's 2. And 4 seconds. I wonder what's happening in between that time, but we'll have to graph it and see. If the race course is very long, who wins? The tortoise. Because of geometric growth, really.
Never grow higher. Never, ever, ever. Will always beat the tortoise.
At what times are they tied? 2, 4 seconds. Okay? If the race course was 15 meters long, ooh, 15. We don't know that. We're saying in between 2 and 3. So I think we're going to need to go to the... No, that's not what it's saying to do. They're saying what if this was a 15 in here. Okay, who would get to 15 in fewer seconds? So we don't know. So we're going to have to go to Desmos for that. Okay? So we've got y equals 2 to the x, and we got y equals x to the second, also known as x squared. Now what we want to do is zoom in. This lag is killing me. Oh, that is such a cool little graph to examine. If I could just get the internet to work right. Come on. Here we go. Alright, so look. As we predicted, at 2, they're equal, Carson. Before 2, who's winning? The tortoise. Because the tortoise is red. Right? And then after 2, who's winning? The hare, the black one, is higher. Just a little bit, right? Look, they're running like just ahead. So the hare is here after 3 seconds, right? The hare is here, and the tortoise is here. So after 3 seconds, the hare has gone 9 meters, and the tortoise has gone 8 meters. But look what happens at 4. They catch back up, and now who's going faster from here on out? The hare is. And you can see as we go, the hare starts to win by more and more and more. It's growing super fast. So to answer the last question, we got to find where 15 is. There it is. And we got to really zoom in at 15. Oh, there it is. So at 15, right here, who gets to 15 faster, the black one or the red one? Well, which one happens earlier in time? Time is on this axis. So which one gets to 15 first? The black one, right? And the black one is the tortoise. So that's the answer to that question. Okay? The tortoise. Y, C, Desmos. It's close. Okay? Alright, here we go. Alright. Use the properties D is 2 to the t and D equals 2 squares to explain the speed at the following times. So, between 0 and 2, the speeds. Let me think about this. Okay, well, what do we know about speed? We know that distance is rate times time. Which one of those variables is another word for speed? Distance, rate, or time? Speed. It's a rate. So rate is distance divided by time, which makes sense, right? It's meters per second. That's a speed. How many meters do you travel each second? Okay. Well, the tortoise, between 0 and 2, the tortoise is red, right? The tortoise is the red one. It gets the head start. So between 0 and 2, the tortoise, this is traveled 4 minus 1. It traveled 3 meters. Can you see that? I can't. I don't think. Look, at between 0 and 2 seconds, the tortoise started at 1 meter. Remember, it got a 1 meter head start. And it traveled to the 4 meter mark. So how far did the tortoise go in those 2 seconds? 3 meters in 2 seconds. Okay? Come on. Come on. So, the interval is 3 meters in 2 seconds. That's not how we would report our speed. What's 3 divided by 2? 1.5 meters per second on average. Whereas the hare started at 0 and went to what? It went to 4, right? Because it was 2 squared. Started at 0, also went to 4. They were tied. Okay, so that would be 4 divided by 2. So who's going faster for the first 2 seconds? The hare. Okay? From 2 to 4. Okay, let's look at the red one. Starts out at, from 2. So from here, from 2 seconds to 4 seconds. Oh man, we're going to have to, there we go. Love this thing. Alright, so at 2 seconds, let's look at the hare. The hare is at 4, and at 4 seconds, they're both at 16. Okay. So, that's true for both of them. We know that actually. So, it's taken 2 seconds, and they've traveled 16 minus 4. They've traveled 12 meters in 2 seconds. So that's 6 meters per second. The other one has also traveled 6 meters per second, right? It's also traveled, if you look at that graph, it went from 2 to 4, and it went from 4 meters to 16 meters. They have those 2 points in common. We already knew that. So this is also 6 meters per second. So they're tied. Okay? From 4 to infinity, oh man, the speed? Well, you could use calculus, but you don't know calculus. So, explain the speeds of the tortoise and the hare. Well, we know who's faster, right? So the tortoise is faster, but we don't know how to calculate the actual speed until we get to calculus. We could estimate it, but they're at different points. So we're going to just move on with this video, okay? If you're following along with this video, you're doing awesome. Love it. We're almost done. All right, so now some homework questions. Identify which of the following representations are functions. Have you ever heard of a function?
Yeah.
Do you know what the test is for a function? The vertical line test. A function tests whether or not our machine works properly. Are there any repeat inputs here? There are. At this point in time, we put in a 2, and what did the machine pop out? It popped out a -1. But later on in the day, we put in a 2, and what did the machine pop out? A 5. So the machine's broken. So this is not a function. Okay? To fix it, this would have to be a -1. Okay? All right. Is number 3 a function? Yes, it is. Okay. Is number 5 a function? No, it is not. How would you fix it? It would only have to be one or the top or the bottom one. Okay? Does that make sense, Carson?
Yep.
All right. Let's do one more example because this kind of goes along with the video, and then we're going to let you guys do this on your own. If you have more questions, just turn them into the question board. All right. Oh, I love number 7 already. Look at the graph. Which car is on cruise control? Which one is it? A. How do you know? It's a constant rate. Right? That's what linear functions have. A constant increase. Okay, which car is accelerating?
I would say
that would be B. Okay, how do you know? Rate of change appears to be increasing, right? It's getting the shape is getting steeper. Okay. Identify the interval in figure 1 where car A seems to be going faster than car B. Well, that's from here to here, right? And so that's like right around there. So if these are 1 unit, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. So as x goes, that should be a bracket.
On the test,
Nope.
will the decimals or mostly?
It'll probably won't be decimals, but that's, we'll just get a good answer. I don't know why it's doing that, but it's funny. All right, as x goes from 0, what did we decide that was? 11.5 to 11.5. Okay, and I think that's enough to get you a good start on your homework. Whatever else you need help with, we're going to have to ask in a separate video because 15 minutes is long enough. Boom! Alex, can I get a boom? Boom!